Hello and welcome to the section 1.3 lecture. Today we're going to talk about subtracting integers, subtraction finally. Okay, we've been adding things with the same sign, adding things with different signs. Now we're on to subtraction. I do want to start out and say I really thank those of you that are really watching and listening to these videos. I think that your success with doing this is helping me feel successful in the system and making it to where I feel like we can do this. I don't have to waste the very precious class time that we have doing this. It allows me to spend more time getting to know people and and interacting with you in a classroom environment. So trust me, the number one thing that I can't stand really overall is wasting class time writing notes. I will say these notes sometimes could be a little bit better in the class setting, but since this is all that we had to push out to you, we're going to make it work, and I appreciate everybody that's watching these just to help make that work. Let's go ahead and look at some counter problems for subtracting integers. First off, we're going to use counters. Like I said, we want to model -4 minus -3. Okay. So what I do is I start with 4 negative counters. Sounds like a great place to start. Whenever we're using counters, we're always starting with whatever we have in that first spot. So I've got 4 negative counters here, and I want to take 3 of them away. When I take those 3 away and get rid of them, they are no longer there. They go bye-bye. And what do I have left? I have 1 negative counter. Okay, so what's left? I have 1 negative counter. Wow. It would be more helpful if I could write. And then we want to find the difference. What does that mean the difference is? -1, because there's 1 counter left and it's negative. There we go. Moving on. Next one, and I'm going to work through this one. The picture does not do this very much justice. It doesn't really make it look that good. So I do want to talk through this, and then we'll have to draw the picture on our next one. All right, so we do want to start with 6 positive, right? That's what we do. We're starting with 6 positive because that's my first number. So that's my positive 6. And then I want to take away 3 negative counters. Well, I don't have 3 negative counters to take away. So the first thing I have to do is I have to add in 3 0 pairs because I don't want to change the situation at all. I don't want to change the setup of what we have going. I don't want to alter the overall amount. So I put in these 3 0 pairs all at once with a positive and a negative. And I put in, there we go. I put in 3 because I want to take 3 negatives away. And when it started, I didn't have those 3 negatives to take away. So now I do, though. I have these 3 negatives right here that I can take away, kick them out of the equation. They're gone. And what do I have left? Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 positive counters. So I have 9 positive counters. Okay. So my difference is positive 9. Okay. I know it's kind of weird. Subtraction problem. We ended up with a positive number. It can happen. All right. Now let's try that same scenario for ourselves. All right. So I start with -2. So there, I've got my 2 negative counters. So we want 2 negatives. And I need to take away 5 negative counters, of which I don't have that many, right? Okay, I don't have 5 negative counters, so I need 3 more to give me 5. So I need 3 more negative counters, but I can't just add in 3 negative counters. That changes everything. So I have to add in 3 0 pairs. So I need to add 3 0 pairs, and there are these ones right here. Okay, now that I have those 3 0 pairs, I can take away my 5 negative counters that I wanted to take away. So those are gone. Those are out of here. And what do I have left? Okay, sorry, I have to take away 5 negative. There we go. And so what's left in my diagram here? 3 positive counters. And so my sum, or my difference, sorry, vocabulary-wise, difference, this word right here, means the answer to a subtraction problem, if we don't remember that. So the difference of -2 and -5 is +3. Cool. Communicating ideas here. Suppose you want to model the difference -4 minus 7. Do I need to add 0 pairs? Let's go ahead and look. Counters wise, if I had -4 counters, sorry, 4 negative counters, and I want to take away 7 positive counters, I don't have any positive counters. So I would need to add in those 7 positive counters in order to be able to take them away. The way we have to add that in is to add 0 pairs. So do I need 0 pairs? Yes, I do. I need 7 0 pairs. And you know why? I need 7 0 pairs to be able to take away 7 positive counters that I don't have. So what's the difference? So what happens when I do that? So if I'm adding 7, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then I'm able to take away those 7 positive counters, what am I left with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So the difference is -11. Okay, let's look at our second activity here. We want to look at subtracting on a number line. To model the difference of 5 minus 3 on a number line, you start at 5 and move 3 units left. That's what we do. That's the same strategy as if I was given this problem. 5 plus -3, because when I add -3, I also move left. And that's a big thing in math, is to know that that's sort of what we want to do. If you really hate subtracting, then don't subtract. Add the opposite. So when I'm talking about the opposite, we went 5 minus 3. I'm turning that into an addition problem of 5 plus the opposite of 3 is -3. Okay, so that's what I'm doing. Let's go ahead and use that on these problems here. So we want to turn them into addition problems because we spent so much time working on addition that we just want to use that. So -1 minus 5. That's like -1 plus -5. So we start at -1 and move 5 units to the left. Starting at -1, 1, 2, 3, 4, 5. We end at -6. There we go. Doing the same thing on this problem, -7 minus -3. I want to add the opposite. The opposite of -3 is +3. So -7 plus 3. So we start at -7 and move 3 units to the right in the positive direction. So starting at -7, going 1, 2, 3. And we end at -4. Okay, so again, subtracting a negative is like adding a positive. Okay, maybe you've dealt with that before, maybe not. All right, looking at this one here, describe how to find 5 minus -8 on a number line. Well, we would want to add the opposite. So that's going to look like 5 plus the opposite of -8 is +8. If you found the difference using counters, would you get the same result? Well, let's think about that. If I was using counters, for counters I would start with positive 5. Okay. And then I want to take away negative 8 counters. I don't have any negative counters here, so I would have to first add in 8 negative counters. 1, 2, 3, 4, 5, 6, 7, 8. And I would have to add those in as 0 pairs. So those are all 8 0 pairs. Now I have my negative 8 that I could take away. Awesome. And what am I left with? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we end up with positive 13. Is that the same thing we got here? I think it is. Okay. So we do get the same result. Okay. Sometimes I count explaining as just doing it. Why not? All right. Looking at an example that's done for us using temperature. It says the temperature on Monday was negative 5 degrees Celsius. By Tuesday, the temperature rose to negative 2 degrees Celsius, and we want to find the change in temperature. This is a very big, very important formula in math, is that for any change, we want to go the final. I don't like the word final for that. I want to think about going the end result minus the start. So what did it end at minus what did it start at? That's going to tell us our change. Okay, but let's think about this. What kind of a change are we getting here? Is it a positive change or a negative change? Okay, I think it should be a positive change because the temperature is going up. Okay, so the final temperature is negative 2 minus negative 5, so we write that as adding the opposite, negative 2 plus 5, and then we use our rules for adding integers with different signs, subtract big minus little and use the sign from the big. 5 minus 2 is 3, and since 5 is positive, that 3 is positive. So the temperature did go up by 3 degrees. Okay. If in example 1, the temperature rose by 3 degrees, okay, in example 1, the temperature rose by 3 degrees Celsius. Suppose it fell from negative 2 to negative 10. Is that change going to be positive or negative? There's a really key word here that kind of gives it away. Right here. The temperature fell. The temperature went down. If the temperature is going down, that's a negative change. Let's show that, though. The final temperature was negative 10, and it started at negative 2. Turn that into an addition problem, and it looks like the temperature actually dropped, let's say 8 degrees. Sorry, negative 8 degrees. I said it, then I didn't write it. It's awesome. All right, let's look at a couple problems that we're going to do together here. Negative 7 plus negative 2. When I add those two together, and this is where I really think about just putting those two numbers together, and what do I get? 7 and 2 is 9. Since they're both negatives, that's a negative 9. Number 5, I have negative 1 plus the opposite of negative 3 is 3. Different signs, I subtract big minus little. 3 minus 1 is 2. And since the sign on 3 is positive, that 2 is positive. Write this one as an addition problem. 3 plus negative 5. Different signs, so I go 5 minus 3 is 2. Since the 5 is negative, that 2 is negative. Last one, I have 8 plus the opposite of negative 4, which is 4. Different signs, 8 minus 4 is 4. Since the 8 is negative, my sign is negative. Okay. So let's see. Need a keyword for today. Just to let you know, if we consistently are getting the code word for the videos on the reflection form, if we're consistently getting those wrong, I'm going to take points away. Okay, you got to get that question right to get points. So I'm going to say code word for this one. We're going to go with opposite. You're going to have to figure out the right spelling of that, but opposite will be our code word for today. All right, thanks for watching. Have a good day. We'll see you in class.